In exercise 7.2, we are asked to solve for a problem in one dimension only, so 1D problem, and our particle is subject to a force equals to negative kx. Now, how do we solve it? Well, first of all, we know that F is equals to negative del U. So if we want to find U, because we always want to go and find U for our Lagrangian, which is equals t minus U, U is going to be equals to the integral, negative integral of F dr. Now, we only are in one direction, dimension, so we're going to have dx here, and therefore F is equals to negative kx dx. Therefore, U is equals to 1/2 kx squared. So let's go back and we should put it inside of here. Of course, t is always going to be equals to 1/2 mv squared, which is equals to 1/2 x dot squared. So Lagrangian is going to be equals to 1/2 mx dot squared minus 1/2 kx squared. So now we have to, of course, put it in our formula. So derivative of Lagrangian in terms of x is equals to d over dt, partial derivative of Lagrangian in terms of x dot. So the first part will give us, move it somewhere so we can keep everything under control. So the first part will give us will give us a negative kx. Thus I will get d over dt of our formula, which is going to be equals to mx dot. Now if we derive in terms of d, the right side, we're going to have always negative kx on the left side is equals to mx double dot. Therefore, mx double dot plus kx is equals to 0. So this one is going to be our final answer. Now, one other way we can check if this is correct is by actually taking another approach to our problem. For example, we know that our force is equals to negative kx, but also is equals to mx double dot. As you can see directly, we're going to have mx double dot is equals to negative kx. Therefore, we're going to have that mx double dot plus kx is equals to 0. Now, this one is a fast approach, but it only works because these formulas are easy. When we actually have harder formulas, we always want to go and use the Lagrangian, because it just shows us that it works for a time. But this is just a way to prove that Lagrangian works.